So good morning, everyone. Good afternoon for Australia. Welcome to the hands-on session on how to do phase 2 with MUSE. This is part of the part 3 of our users workshop. You'll find on our page in the program the presentations from the previous sessions, and the videos will come up also quite soon. Today we just try to see how one can start from scratch in phase 2 preparation of an approved MUSE program. And in order not to repeat the material that is already on the website, I decided today to do a different science case, which, as a caveat, I want to stress that it's possibly, maybe, not exactly feasible with MUSE. So it's not intended to be a perfectly valid science case and everything with MUSE, but just a way to show how we can use MUSE and its performance, and in particular how we can go from a scientific proposal to implementing the required settings in P2. So the idea we have here is that we have that we want to observe a protostellar jet. This is the jet you see here, the center of the image. So this is an H2 image, actually a Spitzer image. So the image might look very different at optical wavelengths, but we will assume that we try to look exactly at the same part of the jet and target it with MUSE. Since this is an extended source, so you see here the 5 arc-second bar, we will use the wide field mode of MUSE, since the narrow field mode is too tiny to actually try to cover most of the jet at a given time. We actually want to resolve also spatially the emission from this jet. Therefore, we'll try to ask for adaptive optics. So we'll use adaptive optics in our observations, and we will not, as we will see from images later on, we do not see the target at optical wavelengths. Therefore, we will use a blind offset to acquire the target, and in order to get exactly in the right position on the jet where we want. So we will also use our own background image, as you will see later. So today we'll try to really learn all these possibilities and how to implement them in P2. So just a quick reminder, MUSE is a integral field unit spectrograph, and it covers a field of view in the wide field mode, which is about 1 arc-minute large. So it's this square field of view, and it works with in the AO mode. It works with the laser stars that allow the adaptive optics to work, plus a tip tilt star. So we'll have to be careful to identify the tip tilt star, and for the blind offset, an acquisition star. So before starting with looking at really at P2, I want to say what would be important to look at before starting your own phase 2 preparation. So first of all, it would be relevant to look at the service mode guidelines, which is a page that recaps everything we have, it's very important to know before starting to do your phase 2 on P2. This is, at the same time, it would be important to check the recent changes. For example, for MUSE, we have in the narrow field mode, there is the possibility to use fainter guide stars, natural guide stars as before. So this is written in the recent changes page. And also, I would suggest to look at the instrument-specific news, where sometimes there are news about some aspects of the instrument, for example, what is available and what is not anymore available, or moving of instruments to another telescope, which is clearly not the case for MUSE, which will stay on UT4. But there you will find many other information. And the last thing, it's very important that when you look on the web letter, you also click on the read the feasibility and scheduling comments, where you could get comments on, for example, these targets could not be allocated for this reason, or please be careful that in order to make your observation feasible, you will have to do A, B, and C. So it's really important to read also that part of the web letter before starting to prepare the phase 2. I would also suggest to go back to the MUSE manual as many times as you need during the preparation of your phase 2 material. There you will find information, examples, and many other suggestions on how to prepare your observations. And finally, you have to familiarize yourself with P2. So clearly, a way of to do it is to actually attend this hands-on session as you're doing. But you can also look, for example, at the short video that is available on the service mode guidelines page. Then in order to go really in depth to your phase 2 material, you will have to see if you need to change anything with respect to phase 1. Because in principle, everything that you put in phase 1 as a request must be the same also at phase 2. However, there can be cases where you could change a single target or an instrument mode with respect to what you asked. And this is well described in the service mode guidelines. And in those cases, you have to submit a waiver or target change request, which will take a few days to be approved. And this implies that it's better if you actually submit such requests well in advance before the phase 2 deadline, which this year is 12th of August. Finally, I will now start to demonstrate the P2 environment and how to prepare this science case that we discussed before. So these observations of this protostellar jet. I want to note that I will work on P2 demo, which is an open space where each one of you can practice. For your own observations, of course, you will have to work on the official P2 page, where you will be logged in with your own credentials and you will actually work on your own proposal that should already appear on P2. So I'll start. Okay, so I will start from here just to show that what I will do is also available in other formats on the website. So there is a nice MUSE P2 tutorial where you will have the possibility to look also at different science cases that can then be found also on P2 demo. This is a very useful tutorial. And today I will try to do something slightly different than any of the other of these tutorials, just not to duplicate the material and to give a hands-on idea of what should be done. So we move to this phase 2 demo environment, where you see the main features of P2. So on the left-hand side, you see all the runs that are available. In this case, we look at the MUSE service mode run, which is the only one that is available here. On your personal P2 pages, you will probably see also, you will see the run in P108 that has been approved, and maybe other runs in the previous programs, in the previous periods where you were the PI or the delegated, the phase 2 delegated. You then see, so on the left-hand side, you see your run, and on the right-hand side, you see many different tabs. We'll go through them step by step. You have to, first of all, know and understand what's the difference between these top buttons, where we have details, which is where most of the work will be done, where you have the details of the properties of individual observing blocks, or OBs. You have the overview page, where you see all your observing blocks with the properties. You will have the schedule that it's important in case you want to give priority to observing blocks, or to work and adjust the difference in time link container, which we'll discuss later. And you have the execution sequence, which is actually relevant only for for service mode runs, for visitor mode runs. So for a service mode observation, you will not use this tab. So as you might know, a phase 2 material of a run. So today I will work in this folder, although in principle you will not need to work in folders, but in this case I created a folder which is better in the P2 demo environment. So you will see that a phase 2 material will consist of a number of observing blocks or OBs, which describe how the observations have to be taken, plus a number of associated grouping of the observing blocks, or time link containers if needed, or concatenations if needed. We will go into the details of the difference of these later on, but for now I will start with simple observing blocks. The other part of the phase 2 material that I will not discuss in detail today consists in the README, which includes an estimate of the total execution time of the submitted materials, a description of the observation, which should be clearly more self-explicative as XYZ, and it should actually describe how what is the science goal of your observations, how the observations should be taken, and if there is any peculiarity in your observing strategy. There is a part where you can report on waiver requests, for example, change of targets on change of requested observing conditions and so forth. And you will be able to write here the ticket where this waiver request was approved. And there is then parts where you can stress some critical observing conditions and some time critical aspects of your observations, as well as special requirements for execution or for calibration. For example, that you add a calibration block, which is the CB here, that must be observed in the days following your observations or something similar. So this is a very peculiar tab that is used only when there is really a special request to be done. In general, you will have to fill surely the first part, the estimated total execution time, and the general description. And if you submitted a waiver, also the waiver request. The other part of the run part of P2 consists of the checklist, which in the case of MUSE is empty, but in other instrument asks for different questions. For example, are your finding charts compliant, and many other questions. And you will have to mandatory fill that out before being able to send the material to ESO. And there is this OBX import tab where you can actually add observing blocks from previous runs that you exported as OBX files, and you can re-import them here. And you can also use the P2 API that was described in the first part of this workshop last week. And you will see the video soon on the website. So once we will go back to this tab later, and we will understand what the notify ESO means, notify ESO button means, right after we prepare our observations. So in order to start with your observations, you will have to first create a simple observing block. So to create an observing block, you simply have to click on the OB icon on the bottom left of the page, and you will be prompted with a simple empty MUSE observing block. The first thing I would recommend is to change the name of the observing block. So since this is a special rule of MUSE, we will have to use the mode that we are going to use in the OB name. So we will start with wide field mode, and we call it HH2121. And you will understand that this _1 is because we will try then to do two different observations of the same jets in two different parts. And HH212 is the name of the target. So at this point, there are, of course, different ways to proceed. I will first start with setting the target of my observations. So I clicked on the target tab, and I'm prompted with this page where I can actually write the name of the target if this is a target that can be resolved by Simbad, and I can click resolve. And you see the target has been resolved, it has been found, and the coordinates of the targets have been imported in P2. If the target is on Gaia, you will also have the proper motions of the target, which is also very relevant for many observations, but in this case, we'll leave it to 0. All this information can be also manually changed, so you can actually, if you know the proper motions of your targets, you can actually manually add it. And remember that this is in arcsecond per year, as you see if you move the mouse on top of the tab. This is, remember, very different than, for example, the Gaia catalog, where the proper motions are in milli-arcsecond per year. So be careful with the units here, because otherwise you will observe an empty patch of the sky, most probably. As you will see, in many parts of P2, if you move above, for example, names or tabs, you will have this pop-up window that help you to understand the format of the information that you have to insert, and so forth, and so on, and like this. So we have now the target, and the target tab filled in. We can start with describing how our observations should be carried out. So we go back to the observation description tab, and we type in a name for our observations, which is HH212 wide field mode AEO. And we check if we will need to add something specific. Doesn't look like. And we then move to defining the acquisition template. So in order to do any observation with any instrument, you will have to first acquire the target. So in our case, we want to observe with MUSE wide field mode in adaptive optics mode, and we only have only one possibility for acquisition template. The other ones, as you see from names, are for narrow field mode, wide field mode with no adaptive optics, and we will thus choose wide field mode adaptive optics. We select it and we click Add Template. At this point, you see that we have an acquisition template in our observing block. In this acquisition template, there are several parameters. We will not go through each one of them, but you will start to see that there are some parameters that must be changed and some parameters that can be changed. In the case of this acquisition template for MUSE, they all can be changed and none of them must be changed. So the integration time, which gives you how long you should open the shutter to acquire the target, is set as default to 1 second. So if you know your target is faint, you can make this longer, but you can also leave it to 1 second, and it can be set also by the observer at the telescope at a later time. The other parameters, so the perform acquisition with tip-tail star is we will let it to yes, so true, because in this case we will use tip-tail star for the observation. In rare cases, you might prefer not to use a tip-tail star, and in this case you will have to click here and set it to no. We will set it back to yes because we will like to use tip-tail star here. The slow guiding is something that, sorry about that. The slow guiding system is a system that actually detects so astrophysical sources in the metrology fields, and corrects for small motions of the telescope. This is something that is done every 2 minutes or so. This means that if you have observations that are shorter than 4 minutes, you probably don't need this slow guiding system, and you can save some overheads. In our case, we will leave it to yes, because we will take exposures that are longer than 4 minutes. The other parameters, we will leave them as default for now, and we will see later how to change them using obsprep. We only look at the last one, which is the instrument mode, where you have two different possibilities. You have the wide field mode AO extended and the wide field mode AO nominal. This implies you can read more information in manual, but the nominal mode covers a different wavelength range and show a smaller wavelength range than the extended. Yes.
Arlo, you should know that at least on my display, when you click on a pull-down menu like that, I don't see the choices.
Okay.
I only see the default one.
Okay.
I don't know if others are having the same experience, but that's what I see.
Okay, good to know. So I will describe more what you see, but you can of course also try it yourself. If you want even to look at P2 demo right now, you will find the MyOP, and you could in principle also play with it, but don't exaggerate, otherwise you mess up the hands-on session. But thank you, Lowell, for letting me know. So we'll select the wide field mode AO nominal. How do we set up the other parameters? So the other parameters of the acquisition can be set up either manually, again, so if we know exactly how to perform, so the right ascension of the Vlt star, the magnitude and everything, or, and I would suggest to use this second possibility, using the obsprep tab. This obsprep tab is actually a very powerful tool that we have to be able to prepare observations with almost any ESO instrument. As you see, this obsprep tab consists of two sides. On the left-hand side, you see several sub-tabs, let's say, and on the right-hand side, you see an Aladdin image, and you can actually move around here. So this Aladdin image is done with a background image that is default here. In this case is DSS2 red, and can be changed, for example, using a background generated from the Gaia catalog, where the stars will be larger depending on their magnitude, or uploading a peculiar image. And we will look into that right away. But so first of all, you can also look at different images from Aladdin. For example, in this case, it's nice to look at the Spitzer image. Wait, not Spitzer color. Okay, the WISE image is probably better, because in the WISE image, you start to see the jet that we want to look at. So you see that we are in the right place of the sky, and this is actually helpful for the rest of the observation later on. But to prepare for the acquisition of the target, I do not need to see exactly where the jet extends, and I will stick to the default image for this target. So what I wanted to say is that what I wanted to do is I wanted to acquire the target with a blind offset acquisition, because as you see here, there are no stars or no bright stars in the field of view of MUSE for now. So there is the possibility of actually selecting other stars that can be used to center the telescope, and then the telescope is moved back to the position of the target using relative motion between relative coordinates between the position of the acquisition star and the target, the science target. So if you click on the blind offset tab of obsprep, you will actually see that some of the stars on your image are starting to color. And if you go above them, you see the properties of the stars, including the proper motions and the R band magnitude, which is the relevant parameter for deciding whether a star whether a star can be used for blind offset acquisition or not. So the stars that are shown here, they are all usable. You see their magnitudes are around 15 to 17. So you can select, for example, the brighter one as acquisition star. And if you click on this one, you will see that it changes. It becomes acquisition star. It copies, OBSPrep copies the information about the star in the right ascension declination and all the and R band magnitude, and also calculates the blind offset from the coordinates of your targets to the acquisition star. If you see this blind offset, which is 54 arcsecond both in right ascension and declination, and you go back to the observation description tab, you will now see that this offset for the target has become this 54 arcsecond both in right ascension and declination, whereas before it was actually 12. It was actually 0. So you see that we prepared now how we do the acquisition of the target. We will do blind offset from this acquisition star, and we will move the telescope back to the target with these offsets. We can now also set the adaptive optic stars, so the tip-tilt star, and we can again click on this tab on OBSPrep, ESO stars, and again see which are the stars that are suitable to be tip-tilt star. In this case, we'll not have the 17 magnitude stars, but we can select again the acquisition star that can be used also as tip-tilt star during the observations, and will become now tip-tilt star 1. It is optional, but one can also select a second choice for the tip-tilt star, which in this case is this other star, which will become tip-tilt stars 2. And the coordinates of these two stars are then shown here on the left. And these same coordinates are automatically copied here, where you see tip-tilt star 1 and tip-tilt star 2 with their coordinates and magnitudes. As you see, if you use OBSPrep, all these fields of the acquisition template will be automatically filled. Therefore, I strongly recommend to use this tool, OBSPrep, to prepare your observations. So now that we set up most of the acquisition template, I want also to include a science template. So after we acquire the object, we'll have to observe it. And again, we can choose between MUSE narrow field mode AO, which is not our case, MUSE wide field mode no AO, which is again not what we want to do, and MUSE wide field mode AO templates. So we select the wide field mode AO template, and we add these to our observing block. So now you will see we have an acquisition template plus a science template. And this is clearly identified by number 1 acquisition, number 2 science. As you see here, this science template has more fields that must be filled. So the fields that must be filled appear as red boxes that must be filled with some values. And these are in particular the number of offset positions, the relative offsets between the observations, and the integration times. So why is MUSE asking why is P2 asking for some relative offsets? This is because it is clear for MUSE observations that a combination of small dithering patterns plus rotation of the field of view by 90 degrees allows for a much better cosmic ray removal and gets also a more uniform combined data sets in terms of noise. So we encourage users, if possible, to perform these rotations and small offset between the observations. Again, in order to set this up, we go back to the Obs Prep tab, where you will see that there is an Observing Offsets tab that can be used to describe how we want to do our observations. So in order to prepare this, I would like to upload an image to be used as background of my observations. So I will click on upload and I can select an image from my computer. Since I've already done this before, I can now select this image, which is a Hawkeye image of this jet that was obtained during a science verification run of RAL, and has a large enough field of view such that I can plan my MUSE observations using this image. So you see now the difference with respect to the background image, where we not only have the stars that we selected, but we have a nice image of the jet. In order to set up the observing offsets, we can use different strategies. We can either put the right ascension and declination coordinates in the manually on the left-hand side, in sky coordinates or in detector coordinates, as we prefer. And there is a thorough description of the difference on the manual. I will work in sky coordinates. Or we can simply select a part of the image, a part of the image where we want to perform our observations. So if we click on the image, we will be prompted with a new field of view of MUSE, and we will see what is the right ascension and declination relative offset with respect to the target, which is about here at the center of the jet. So we will try to cover this southern part of the jet with our observations. And as I said, we would like to cover these with with 3 exposures rotated by 20 degrees, by 90 degrees, and having a small offset of about 0.3 arc second. It's recommended to do it more than 0.2, 0.25, and less than around 1 arc second. But as you see here, this position angle of the MUSE field of view is probably not the best to actually collect more information about the jet. So we'll also start with a small rotation of the field of view of about 20 degrees, which will allow me to position the jet exactly on the longer axis of my field of view. So this will allow me to cover a larger fraction of the jet with one image. So in order to finally, this will be an object observation, whereas if I want to take sky observations, I will have to click on S, which stands for sky. In our case, there is enough sky around the jet that we don't need to take observations of sky in other parts of the sky. So in order to add other observations to our template, scientific template, we can either do it manually, as I will do, and I will do an offset of 0.3 arc second in right ascension and 0 in declination, plus a rotation of 90 degrees, and I will add these. There is an error, of course, because this is how you do hands-on session, you get issues. Sorry about that. Okay, let's try it again. 0.3, 0.90. And yes, it worked. So you see here that we have 1 and 2. They look very similar, these two observations, because they have very small offsets, but they are actually two different field of view with a rotation of 90 degrees between the two of them. I will then do another offset. This time I will do 0 offsets in right ascension, 0.3 in declination, and again a rotation of 90 degrees in position angle. And I will also add this observing field in my template, and you will see here again that the 3 rotation will appear in ObsPrep. So now why is this ObsPrep so useful? Because if you go back to observing description, you will actually see that some of the tabs that, or the box that must have been filled are now filled automatically by ObsPrep. So ObsPrep already told to the science template of this OB that we will do 3 offset positions, and the observation type is always object. We'll have 3 relative offset in position angle and in right ascension and declination, where the first one in right ascension and declination is quite big because we move from the center of the target to that part of the jet. What remains to be added is the integration time at each exposure, which I will put to 360 seconds, just for demonstrating how it works. I do not guarantee that this is the right exposure time on target for this specific science case, but it's just as an indication of what people should do. So at this point, our observing block is almost defined, at least the part regarding how to carry out the observations. So if one clicks, for example, on this exposure time button, you will see that in order to carry out these observations, which have an exposure time on target of 18 minutes, so 3 times 6 minutes, the telescope will take about 35 minutes. This includes the overheads of moving to the target, of the blind offset acquisition, and of all the readout and everything as described on the manual. At any time during the preparation of my observing blocks, I can check if I'm doing things properly. So if I click on this check button on the top left, I will get this pop-up window, which clearly shows that the observing block is not yet ready to be submitted, as you see from this red downside looking button. There are some errors in my observing block, and I can read through the messages to understand what I did wrong. So for now, one issue is that AO observations can only be performed at air mass 1.9. And this is okay because we did not look yet at the constraints of our observations, as we will look soon. And the other error is that we do not have a finding chart for observations, which we still have to prepare. And these are 2 errors that must be fixed, as clearly written here. There are also some warnings. One is that the target seems to be missing from the target list in the proposal. This will stay there because we are on P2 demo, but in your proposal, it should not appear unless you asked for a target change request. And there is the request to verify that the target remains inside the field of view during the dedirect pattern, which is something that we can check later. So let's go back to the air mass constraint. So as you see here, we looked for now at only the observing description tab, at the target tab, and the ObsPrep tab. However, there are some other tabs that are very relevant for preparing the observing block. There is the constraint set, which is exactly where we set what are the constraints that we want to put for our observations. So this will tell when the observations can be carried out in service mode, meaning that if the conditions are worse than the ones I inserted, then the operators at the telescope will not be able to select my observing block to be observed. These constraints are set by what you requested in phase 1. So if in phase 1 you requested a sky transparency of thin, you will not be able to select clear or photometric here. If you selected clear, you will not be able to select photometric. So for this example, I will assume I can request clear observations, so clear sky transparency. I will put a limit on the air mass at 1.8, and I will leave lunar illumination. It's the FLE parameter that you inserted in phase 1, and I will put it to 1 in this case because I decided that the moon is not an issue for me because I care only about the reddest part of the spectra. For image quality, this is actually something that in AO observations is ignored, and the relevant parameter is actually the turbulence category, which in this case, based on my science case and what I requested in phase 1, I will set to 30%. So as you see here, now that I changed the air mass constraint, if I check my OB, the error that appeared before is gone. There is still another one, which is about the finding chart. So before moving to the finding chart, I go back to OBS prep for a final aspect. So we looked at the pointing, we looked at the AO star, we selected the tip tilt star, we looked at the blind offset, and we looked at the observing offsets. Now there is a final tab, which is Vlt Guide Star. This is a tab where you can select, you don't have to, but you can select your guide star for your observations. And you will see many of the stars in the field of view, actually not in the field of view of MUSE, but in the larger telescope field of view, that you can select to guide the telescope during your observations. Please be careful that you select a guide star that is available for all the observing offset. In this case, the observing offsets are very small, so any star more or less it's possible to be used. And also be sure that this feature that appears here will not cover your observations. So here today I will select this star to the north of my target as guide star. And this will be, again, copied. The coordinates of this guide star will be copied here in the acquisition template in the observing description. So now I set up everything on OBS prep, and I can go to finding charts. Finding charts allows me to generate finding chart based on the observations I put in the OB, in the acquisition template, and in the science template. So this is automatic, and in the case like the one I just shown, where I have uploaded a background image, this automatic tool will generate a number of finding charts, including one using the image I uploaded. So you will see that in a few seconds, this finding chart is generated. It has a status green done, which is good, with a caveat that no slow guiding stars are found for the field of the object, which is a caveat that we have to keep in mind because we might have to go back to the observing description and deselect the slow guiding system since there are no slow guiding stars to be used. But you will see here that the finding charts have been generated. There is one that uses the background image I upload, where you see the jet. And you see here that the position of the reference star, so the acquisition star, and of the tip tail stars is shown. It's shown also the field of view of MUSE acquisition and the observations. So with the three different rotation of the field of view and the small offsets between the observations. This is also shown in the on the standard background image of P2, which doesn't show the nice jet. And it's also shown on a larger finding chart that shows also the selected guide star, the guide star we selected with upspread. So all these finding charts are compliant with what we request because they show the run ID, the name of the PI, the name of the observing block. They show clearly all the fields of view and so on. You can also, of course, upload your own finding charts, but since this tool is very easy to use, as you've seen, you just need to generate finding chart. Then it's very easy to I would suggest to use this as much as you can. But if you like to upload your own finding charts, you can click on upload finding chart and you will be prompted with the request to upload the finding chart. You can also upload a background image here, but you can do it in the way I did on OpsPrep. So there are, as you've seen, there are a few other tabs that I'm not using here now. So there is a time interval where you can select. You can say that, for example, that your observation, for some scientific reason that must be very well motivated, can only be carried out between the 2nd of November 2021 and the 5th of January 2022. You will see at this point that there is a green bar showing, sorry about that, showing when you want your observations to be carried out. And you can also expand this. Yeah, you can also look it more carefully, but for now, this is actually not important for observations, so I will delete it because there are no scientific reasons to use it. There is also an ephemeris tab where you can upload ephemeris file, but again, since this is not a moving object, we don't need to upload any ephemeris file. Finally, there is a target visibility tab, which is very interesting if you would like to check when your observations can be carried out. And in particular, one thing that one would like to check is, for example, what is the air mass that your object is getting to. So let's assume that this object will be observed in P108. I select the night in P108, and I see that the object clearly gets to air masses of 1.1, as you see from the y-axis. This means that the constraint I put of observations done at air mass lower than 1.8 are reasonable because the object will be observable during the period. So I can now check again the OP, and you see now I have green light. It seems everything is fine. I have some warnings, the same as I had before, that I will leave them as they are. And I have an info message telling me that I relaxed the lunar illumination constraint, which is something that could be intentional or could be a mistake. If it's a mistake, you can go back and correct it. So now we have seen that we cover with our observation this part of the jet, and I would like also to add another observing block that looks at the other part, at the north side of the jet. So there are multiple ways of doing this. The way I will do it, which is pretty quick, is I select again the OP, I go on edit on the top of the page, and I duplicate the OP. So if you duplicate an OP, you will get another observing block that is exactly the same as the previous, with then 2 appended at the end of the name. I will now change the name to 2. So we'll have wide field mode HH2121 and HH2122. And I will double check that the observing description is the same. The target is again the same. The constraints are again the same. The finding charts are also the same. And this is, of course, not correct, because I will want to observe a different part of the jet. So we'll go back to obs prep, and I will leave exactly the same AO stars and exactly the same blind offset. So to be sure that I get exactly to the same position in the sky as for the first observation. But I will then change the observing offsets. And in order to change them, I will again select my uploaded image. And I will move these, I will select another observation, another point of the of the jet that I want to observe, and I will copy manually these observations. So this is a little bit of a trick that I'm using to be able to force the telescope to go, yes. So of course, this is not easy, so I will do actually, so you see, it's not always trivial to do things, but we can, okay. So we'll do another way. I will, yeah, I will start again. I will reselect the part of the sky, the jet I want to observe. I will set again the position angle to -20 as before, and I will insert the other observations as I did earlier on. I will insert an offset of 0.3 arc second, 0 arc second, and 90 degrees. And then 0 arc second, 0.3 arc second, and 90 degrees. Sometimes you have to be a little bit patient with this tool. I will leave the rest unchanged, the guide star and everything. I will check that now the offset for the observation is positive, so it's different than the one of the other OP. And the rest will be unchanged. So the observing, the exposure time is the same and so on. I will then go to finding charts and generate new finding charts. This is important because I changed the position where I want to carry out observations. So it's very important that, that I generate new finding charts. So this is, as before, something that is done automatically based on the information I put in the OBs. I will so sorry, I'm not asking, but if anyone has questions, feel free to ask. I mean, we can also do it. I'm almost done. We can also do it at the end of this, but you can also do it while we go. So in this case, I get no messages, no bad messages from the tool, and I have my new finding charts that you can compare with the previous one to see that I cover a different part of the jet. Okay, so at this point, I can check that also this OB is fine. I get the same issues and as the same warnings as in the previous one. For the rest, this OB is observable. We should now discuss a little bit about the strategy. So now, if I were to send these observing blocks to ESO, these will be observed at random times during the period with no relation between the two of them. I could actually decide to group them by clicking on this G. A group will put them together, and especially if, let's say, my science case is to observe 10 of these jets, but I want always to observe both sides of the jets. So let's say this side and this side. If I group them, once one of the side is observed, the other OB will get priority over the other OBs in my observations, in my run. So this might be a good choice for us, but in this case, I will not choose it. Another possibility is to time link them. And time linking them means that if the observations for one OB are done, those for the other OBs must be done within a certain difference in time. So I will use this here, I will call it HA2 time link, and I will do the following. I will select the two OBs, I will click on copy, and then I will click on the time link and I will click on edit, paste. At this point, you see you will have the two OBs that I prepared before in a time link container. And if I click on the exposure time here, you see the exposure time of the time link, etc. And again, if you then now go on the schedule tab that we looked at before, you will see that you will not only be able to set the priority like here, but you will also be able to set the difference in time that can be used, that is allowed between the two observing blocks in one time link container. So at this stage, they must be observed one after the other. But I could say that my observations are still relevant if they are observed within 10 days, one from the other. Let's see if the tool accepts this. Okay, it's not. Let's say 10 hours. No. There is an error, which I think is related to P2. I'll assume this is a P2 error, and I'll assume that it actually went smoothly, and I could actually say that the observations must be done within 10 days from one observing block to the other. This means that when that first one is observed, within 10 days, the second one must be observed. And this is something that is used to populate the queue at Paranal. So this is another way of linking these two observing blocks. And the final way is a concatenation. A concatenation is different in the sense that the observing blocks are observed one after the other, so directly with no time in between. So if I put these observing blocks in a concatenation, as soon as observing block 1 ends, observing block 2 starts. This is probably not what we need for this science case, unless, for example, this object is variable on very, very short time scales. And in order to look at both parts of the jet, I really want to observe them simultaneously or almost simultaneously, so one after the other. This is an interesting aspect here is also that, as you note, the execution time for this concatenation is 1 minute, 1 hour, 5 minutes, whereas for this time link container is 1 hour, 10 minutes. So this 5 minutes different is based on the fact that the target is the same in both observing blocks. And if they are observed one after the other, it will be faster for the telescope to start the new acquisition. So this actually saves a little bit of overheads, but be careful that this anyway makes the observation go above the usual 1 hour rule that we have for the length of the observing blocks. And indeed, if I look at if I check this concatenation, I will have an error which can be waiverable, which is that the execution time of the concatenation is longer than 1 hour, 5 minutes. So if I want to actually carry out this observation, I need to send a request to waive this error for our observation and justify this scientifically why I need to do this concatenation and why I actually need 1 hour 5 minutes and 1 hour and 4 minutes will not be enough. So at this stage, I cannot submit this concatenation, and I will have to ask for a waiver. So this already showed most of what one can do with P2. What will be done at this stage is that I will then go back to the top of the run. I will go back to this run info page, and I will double check the README. I will double check that the general description includes all the information the observer needs to have to carry out my observations and check the quality of the data, that all the waivers have been requested and approved. I will check the checklist that is filled. Then I will go back to run info and I will press notify ESO, which I'm not sure what happens on P2 demo. I will try anyway. Exactly, so there are no certified items in the run, which is also a very good point. So if I go back to my observing blocks, I select the 2 of them and I now click certify. Because the check I carried was just a check for myself, that everything works. Certifies sets that observing blocks in a new status. So the status is now defined. And you see this because the observing block name is grayed out. And you cannot modify this anymore. You can actually not modify this in this mode, but until you press notify ESO, you can still revise the OB. So if you say, oh no, I need still to change something, I can revise it and it becomes again colored and I can again modify it and then certify again. So let's now go back to, to the top of the run and click notify ESO. What you see is that this notify ESO has actually sent these 2 OBs for review to ESO. These 2 OBs names are listed here, and if you do not see your OB names here, it means they were not certified and they will not be sent to us, to the support astronomers. This in principle concludes the first part of the phase 2. At this point, what happens is that one of us at ESO will look into your material and come back to you with either comments or saying that the material is fine and can be used for observations. So this is it from my side. I hope that you understood something and that you're now more familiar with P2, but I'm very much happy if you are going to ask me any question or doubt that you have. Everything you do is automatically saved on the fly. So this is the advantage of having this online. So if you lose the connection, you will then be able to get back everything you've done because it's automatically saved. And you will see while you work, if you're modifying something, that this is still modifying and then this red thing disappears and you're done. So if you have other questions, you can ask them there or contact us going on the support.eso.org website and submitting a ticket to us, and we will be happy to help you. So if there are no further questions, I will close here.